The next concept we want to look at is composite functions involving trig functions and their inverses. So remember, a composite function, if I have f of x equals x plus 2 and g of x equals x squared, the composite function f of g of x comes when I put g into f, like this. So that would be x squared plus 2. Or g of f of x is when I put f into g, so that would be x plus 2 squared. So that's a composite function. So we're going to look at what that means in trig. So when we have a trig function, the composition works in a similar manner. So think about if you had the function sine of the inverse sine, that's sine of inverse sine, and let's pick 1/2. So the question is, what is the innermost function there? So we have the sine of the inverse sine of 1/2. Well, that's going to be right here at pi over 6. And the sine of pi over 6 is 1/2. Notice this is the same as our answer. Or we could have the other flip side to that, the inverse sine of sine, and let's say pi over 6. So in that case, we would get the inverse sine of 1/2, which is pi over 6. Again, note this and this are the same. All right, one more example where that won't be the case. So now we say the inverse sine of, well, sine 5 pi over 6 is 1/2. But now, because the sine goes from here around to here, sine 1/2 is not the same as 5 pi over 6. That's not in the domain, or I'm sorry, the range of this function. So for this, we would then get, again, pi over 6. So in this case, notice that these are now different. And that leads to what they say on page 571. Composition of trigonometric functions. The sine of the inverse sine of x is equal to x for all x in the domain of the inverse sine. So, if the value, the argument of your trig function, the number inside, is in the domain of the inverse function, then it's true that sine of the inverse sine of a number, you just have to take the number. If x is in the domain of inverse sine. So we would have an issue if we said sine of inverse sine of 5 pi over 6. That's not an option. Now we have an issue that has to be dealt with. So that would not be equal to 5 pi over 6. But as long as it's in the domain of the inverse sine from negative pi over 2 to pi over 2, then it's just equal to the variable. Let's look at example 3, where they give you one more example of this. Cosine of the inverse cosine of root 3 over 2. So, pulling out our trig function here, we're looking for the inverse cosine. And so inverse cosine is from here, 0, to pi. So it has to be on this upper half of the circle. So when is cosine pi over 2? Well, right here. So that's going to be pi over 6. So we'd say cosine pi over 6. So the cosine of pi over 6 is root 3 over 2. Using what we just learned, we could say, well, since root 3 over 2 is in the domain, it's one of the options, we could say that cosine of the inverse cosine of root 3 over 2, without doing any work, is root 3 over 2, because it's in the domain of the inverse cosine. And that's what it's asking us to do. So, look at that second one, though. So the second one is sine of the inverse cosine of 1.8. Now, notice that 1.8 is greater than pi over 2. So 1.8 is not in the domain of inverse sine. So we can't evaluate it. We can only evaluate it if it is inside the domain. So, that's what we're doing with problems like this. And I'm sorry, that's not from, we're talking about range here. It's outside the, so that's because it's greater than 1. Because again, from here we have our domain is from -1 to 1. Our range is from 0 to pi. So it's bigger than 1 is the problem there. Alrighty. So that's what we're working on with these problems. So as you're going through these, take a look at those special cases. We talked about those. And then you have to check, is it in the domain? And if not, what happens with it?